Can everyone hear me? Okay. Yes? No? Let me see here. Try to adjust this. Is this better? Yeah? Okay. So this is, I didn't realize when I was coming in here today that I was stepping into the great shootout of purely functional, statically typed languages. But this is a good set of topics to be close together with a discussion on OCaml and Haskell. So before I get started, I'd like to ask you, how many of you are working with something like OCaml or Haskell right now? Basically those two languages. So we have a few people. That's great. How many people are working with other functional languages of different types, like Scala, Clojure? Erlang. Sorry, I feel like I committed a great sin here by not mentioning Erlang. That's great. So how many people are frustrated imperative programmers in other languages? JavaScript, Ruby, Python? So there's quite a contingent of discontents in the room as well. And so I think that this talk is relevant to people from a lot of different backgrounds. I started thinking about this maybe a couple of years ago when I initially started using Haskell. And I wrote a blog post actually almost exactly a year ago about how I'd like to be using more Haskell. And it was pretty well received, but at that point we weren't really doing much Haskell in our company. I run a consultancy called Stack Builders, and I'll get a little more into the kinds of projects that we do in a moment. But we were mostly doing Ruby projects. In fact, almost 100% of our projects were in something like Ruby, combined with JavaScript, of course, and a little bit of Clojure on the side as well. But we embarked on this journey of starting to switch the organization more to Haskell. And that was about a year ago when our company had 25 Ruby developers. And we've changed quite a bit since then. Now we have about 20 Ruby developers and 5 to 6 people doing Haskell full-time. And I think that's a great change. I think it's been very much a success. And I wanted to talk a little bit about how we did that and how we've been able to transition some of our projects to Haskell. So how many people know about how many developers there are in the world? Anybody want to take a guess?
5 million.
5 million? It's a good guess. 20 developers. The rest are just amateur hacks. For 20 million. Okay. Good. So these are pretty good guesses. There are 11 million professional developers, somewhere around there. And maybe another 7.5 million or so hobbyists. And how about how many Haskell developers in the world?
5 or 6.
5 or 6? Yeah. Well, I can tell you that there are about 5 or 6 in Ecuador. We have our office. I think I don't really have any good numbers on this. I've been talking to some people at other consultancies that do some Haskell work, and we think that maybe around 1,000 professional Haskell developers, and maybe that's even optimistic. So not very many people doing Haskell right now. Maybe we're talking about like 0.01% of all developers doing something like that. If we added in the OCaml people, then maybe there's like 0.0015 or something. I don't know. Not a huge community. But we'd like to change this, and this is part of what this talk is about. In the end, I was joking a moment ago about this being the great statically typed language shootout, but I think that in many ways it doesn't really matter so much to me. I think that I would like to see people change more towards languages like Haskell or like OCaml. But in the end, I think that it's a positive direction in general, and whatever happens, if Haskell died out tomorrow, then I'd probably happily switch to OCaml. But I think that so going into a little more about Haskell's popularity. It's not kind of a distribution of just Haskell programmers all over the world. There are places where there are more Haskell programmers than others. And I think that in the city that I'm from originally, in the city where we started our consultancy in New York, it's actually a pretty vibrant Haskell community. And a pretty vibrant community for purely functional, statically typed languages in general. And when I talk to people from San Francisco, in Silicon Valley, a lot of the time they say, hey, I wish I was in New York because they have more of an FP community, at least in the Haskell and ML tradition. And so I'm very lucky to have been from this city where we've got 60, 80 people at a Haskell meetup, and so that's a very strong community. On the other hand, you've got sorry, I'm looking at I was meaning to switch these slides before. So let's talk a little bit about why we would use Haskell, and this is what I'm going to talk about in this presentation. First of all, why we would use Haskell over things like Ruby, and I'm going to give you some case studies of what we're doing with Haskell, and I'm going to talk about some of the good aspects and some of the bad aspects of Haskell. And then also, how are we selling Haskell? And I think that a part of what we're doing as software developers, even though it might not be our favorite role, is how to sell languages like Haskell, and how to sell things like processes. And then I'm going to talk about the future, what we're doing and what Haskell is doing. So a little bit more about our company so you have slightly more context. We started in New York, and I'm originally from Western New York. A place that probably has a similar cold and snow to Poland at certain times of the year. We started our consultancy in New York City, and then I moved with my wife to Quito, which is in Ecuador in South America, right along the equator. We're about 15 minutes south of the equator, and this is one of the views that we have from our office sometimes of Cotopaxi volcano. So it's one of the highest active volcanoes in the world.
Not your headquarters? No.
Not our headquarters. No, we're not located on the volcano. But yeah, it's about 5,897 meters, and even though it's on the equator, it's snow capped all year because of the altitude. So as I mentioned, there were no Haskell programmers in the entire country before we started, and so I think that this is. What's that?
No programs at all.
Yeah. Well, no, they do have several academic programs in computer science. They tend to be quite applied and focusing on development tools, especially Windows platform tools, things like Java and Eclipse. But they have a decent enough amount of theory and other background to be able to pick up Haskell. And I think that this is a really interesting case study for adopting Haskell because you don't need to have these academic programs that emphasize category theory and everything to be able to grow productive Haskell programmers. But I'll talk a little bit about that in a moment. So what are the kinds of projects that we do? We essentially have medium to large scale web-based systems. And this puts us in even more of a distinctive position with respect to languages like Haskell and ML, in that most people who seem to be using these languages, at least to me, are doing things that are computationally intensive, AI things, data processing things. And what are we doing all day? I mean, we're basically just talking to APIs, and so. This puts us in rather a select group of people using Haskell. And I think that even though we're in a relatively small niche, it's actually a language that really helps us out a lot. So we're doing systems currently in Haskell that are related to real estate, so kinds of content management type systems. We're doing systems that are related to finance and to banking, especially for clients in New York, since that tends to be a popular industry there. But it's not something that you need Haskell for. It's something that we're basically building systems that are kind of like what you would do in Ruby on Rails. So I want to spend a little bit of time justifying why we're making this kind of change, and I think that I should say a couple of words about what I was doing professionally before this. After college, I started doing web programming, and even though I kind of had a background in Java, I started doing work in Perl. And at that time, there were a lot of people doing web applications in Perl. So I picked it up to escape some of the boilerplate code and that kind of stuff in Java. And I got jobs doing professional Perl development. And this is a picture of, has anybody read this book when they started out doing web development in the late 90s? This is Philip Greenspun, and he wrote a book on web publishing kind of earlier on. and it had a lot of cool pictures. It was kind of an introductory guide, but it had a lot of interesting pictures. And that was kind of at a time where websites were talking about, it doesn't just have to be static, it can be database backed and all that kind of stuff. And I think that things have changed quite a bit since then. Then maybe you kind of scrape by on doing things in Perl. But as we've really started to scale out software systems, there have been more pressure points. So I went from doing Perl programming to doing Ruby programming, and I started doing that about 7 or 8 years ago. I had a good run of several projects there, but in many ways, a lot of those experiences directly led me into looking for something that would be more maintainable. So what was some of the good stuff about Perl? As I said, there was less boilerplate. You could have a couple of API endpoints or whatever, or web pages that were all backed by individual Perl scripts. And that kind of worked out okay for really simple systems. Perl has changed since then, but back then I lost track of the number of projects that I would come onto, and you would learn about the object relational mapper that people were using. In fact, you would learn about the object-oriented programming system. Since inevitably somebody on the team rolled their own OOP layer, and you kind of had to figure out the nuances of that, and hopefully the guy is still on the team. But if not, you've got a whole other set of problems. The same kind of thing with interactions with the database. Everybody's kind of writing their own interfaces for that. But it got a little bit worse, and into things like this. I don't know if anybody here has seen this before, but this is a valid Perl program that prints out 99 bottles of beer on the wall. What, you couldn't tell that just by looking at it? Yeah, it is. So this is kind of the Perl version of isomorphic programming. People talk about that with JavaScript all the time and kind of throw that term around. So.
Bottles for a reason?
What's that? I don't know.
Like lines of bottles for a reason?
I don't know. They wanted this to to make it represent the fact that it was going to print out 99 bottles of beer on the wall. So try it out. It actually runs. I think I did it once about 10 years ago. Ruby, like Perl, had some good things going for it, and it still does. Coming from a Perl community where everybody is kind of rolling their own OOP, and I think that's been resolved to a good extent by standard libraries that people are using. But in Ruby, you approach the language with OOP already built in, and it was pretty consistent. You knew how to do things like inheritance and all that kind of stuff, and it worked pretty well. Unlike Perl, it didn't have quite so many special characters, and so it didn't lend itself as immediately to things like obfuscated code contests that were popular in certain parts of the Perl community. And you have a culture that's really, really obsessed with best practices, and I think that this is a really important part of Ruby, and something that cultures and communities like Haskell can actually adopt from Ruby too. But I'll get into that in a minute. Now, it's also got some bad parts, and this is a transformer. And so everybody here who's into functional programming knows that things like mutation can lead to programs that are more difficult to maintain. And this is certainly the case with Ruby. In many ways, Ruby takes the ability to mutate things to an absurd level. How many people have programmed in Ruby here? Okay. So quite a few people. And so you know about the types of things that you can do. You can not only mutate variables that you initially set up as constants, right? The ones you explicitly say and kind of put in a part of the code where they shouldn't be changed. Usually you can mess around with those things. But you can also mess around with classes, right? So you can say, one moment this class has these functions, and then a couple minutes later, it lost one function, it gained 3 others, and all this other sort of stuff is happening. And this actually occurs. You would think that nobody would ever use this. I've actually been on projects where you get an exception, and it says, oh, that method isn't defined on that class. And I'm like, well, it's getting defined over here. Well, it's only defined, halfway through running your program in the course of loading a web page, and then somebody goes in and dynamically adds a method. the presenter Garrett this morning was talking about these moments where you kind of want to slap another developer, and I don't think that you should do that, but I think in these cases that you can just sit back and watch while the developer slaps themselves, right? But all that kind of stuff is possible and done in Ruby. And of course, this makes for really, really unreadable programs. In many ways, I was tweeting about this a while ago. I think that Ruby is the language that perhaps embraces postmodernity the most. So in postmodern social theory and philosophy, what I mean by this is that philosophers talk about fluid boundaries. They talk about identities that are able to shift. And these things are really useful for talking about things like race and gender and things related to personal identity. And Ruby is kind of okay with all of that. It kind of tries to model the postmodern world. It gets pretty crazy at times. The fundamental fact is that in systems of software where we're really writing things that modules and components that communicate with each other, you need to have some basis for stable communication. You can't just depend on sending messages down the pipe and something else receiving it if you've got this other thing that is changing shape in the middle. It'd be like on my ride to my taxi ride to the conference center this morning, and I don't speak any Polish. I can get by in Spanish, and I speak English as well, of course. But as a safety net, I had a map of how to get to the university on my iPhone. And the kind of stuff that Ruby does would be like, I'm trying to communicate with this taxi driver who only knows Polish, and I hand my phone to the driver, and in the middle of handing the phone to him, it turns into a turtle or something, So this is the kind of development that Ruby allows you to do. There's a quote from this, I don't know if you know the country singer, Chris Christopherson. He's not a programmer. He's got a beard like some programmers, but he's a country singer. And he said, freedom's just another word for nothing left to lose, right? And the incredible amount of freedom that comes from with languages like Ruby also come with a huge amount of need for constraint and discipline, right? And I think that this quote really captures some of the problems there. And so this is the ideal of Ruby on Rails, that you have a language where there's only the essential. And you've got a kind of a declarative syntax, that's almost functional in some ways for constructing a web application. But due to things like mutability, and also the fact that usually just the CRUD operations, the database operations in your application, those aren't really the most difficult part about what you're doing. You really want to focus on this business domain that's going to take a different shape anyway. So in a sense, things like Ruby on Rails, they've got these blog posts with like the 20-minute Rails web blog that you can make and that kind of stuff. And it seems like you're really productive off the bat. But what they're really doing is kind of making the simple things easy, right? But that's the stuff that's already simple in the application. So it's helpful, it's good to get to what you're doing, but beyond that, there's still a lot more that can be done. So this is kind of more similar to what we encounter sometimes in Rails applications. And it's not that dream of simplicity and the clear railway, but you have a lot of focus on the inessential. By stripping away things like types, assertions that the compiler can make, if you don't come into a project with a huge amount of discipline, then this is sort of what you end up with. And so what do we do to prevent this? Well, I looked up some statistics on one of our projects, and this is a project that doesn't have much of a website. It's got primarily we're looking at a back end that's communication with a lot of APIs, and we have 8,000 lines of code, regular production code, and 23,000 lines of tests. And this is actually something that isn't that unheard of. Having a 1 to, in this case, a 1 to 2.8 test ratio. Have you guys been on projects like that? Yeah, I think there are quite a few, and I think that testing is a great thing, and I think that Haskell needs to do more of it in the community, and there's been discussion about adding more tests to popular programs in Haskell. But when the idea behind testing and what people experience in testing will tell you is that you should only test what you're worried about. Tests can become a liability as well as an asset in a code base. And the wrong kind of testing or too much testing can lead you down a path where the code isn't more easy to change, but it's much more difficult to change. And this is a heck of a hard task. The talk, the keynote that I'm sure a lot of you were in this morning by Garrett talked a lot about patterns and how we try really hard. Programmers spend years learning these patterns, reading the Gang of Four book. And a lot of that work is because you have languages that don't impose very much structure on you. They let you get away with a lot of things. So you need to manually apply a lot of patterns and practices to try to resolve that tension. And I also don't think that we should go overboard with patterns. And I think everybody's been on projects, as was said this morning, where people did go overboard with patterns. But people go overboard with testing this way too. And so in this sense, everybody thinks of Ruby as being this really, really simple web programming language. I think it's actually incredibly difficult. And in my experience, after working with it for 7 or 8 years, I wouldn't really trust a programmer who's new to Ruby on a project by themselves for at least a few years until they've gotten that much experience. After having cleaned up so many messes and thrown out so many code bases where people didn't have the experience to really do this, it's an incredibly difficult thing to do. So now we're back to Haskell, because based on this perspective, I really think that Haskell isn't the tough language to learn. People say that, Haskell is difficult to learn, you've got to be a math genius to use it. I actually think it's a lot easier than Ruby. And I think that's very much the experience that we've had as a company as well. So things that Haskell does right are that there's been a lot of work done on distilling the core concepts and abstractions in the language. And I'm not going to go into a lot of these in significant detail, but things like the type system and the way that you start thinking about problems in that way really solve the problem of this postmodern Ruby programming language, right? You're not just sort of hacking stuff together and saying, okay, I'm in the REPL and I've got this function that talks to this function, and kind of shaping things as you go. You start out with a set of basic assumptions through the type system, and you say, okay, this is the way that something is, and I'm not going to change that right now. And by starting with those basic things that allow your program to work together, you don't have a lot of the same problems that you have in more dynamic languages, in my experience. So this has really been working out very well for us in the last year, and I'll give you a few examples of the projects that we've taken on. So the first project that we took on, outside of some internal training exercises, was a project that we did for a client in finance in Ecuador. And I think I'm pretty sure this is the first professional software project in Haskell that was written in Ecuador. And it actually went great. We started this application that basically takes in some data from different banks and mashes it up a bit and shows some pretty graphs. And about half of the work was in the back end. And we used the Haskell web programming framework Snap, which you might have heard of. And that worked great. The front end, we used Ember. And Ember is probably familiar to a lot of you who have experience with web development. It's basically a model view controller framework for the front end of websites. And it kind of does for the increasing complexity on JavaScript applications what Rails and similar frameworks do for the back end. And so this might be kind of an interesting decision, using this purely functional language on the back end, but using something that is more like Rails on the front end. It actually worked out okay for us. It helped us to keep development velocity up. We were using something that was really supported by the community. And it was kind of a good trade-off and good point of division in the project to make sure that we had developers who were comfortable enough with working on it while they were getting some of the back-end exposure in Haskell that we needed. So we shortly picked up another project, and this one is done for a client with an existing code base. And I think this is perhaps even more interesting in that we were stepping into, we had lots of situations where we stepped into legacy Ruby projects, and one thing that kept happening to me as I would pick up Ruby projects is that the client comes to me and he says, hey, I've got this code base in Ruby, I want to add on features, it's got to talk to Facebook and read from Twitter or something like that. And usually things are a little more complicated than that too. And he'll give me the code base and I'll say, well, it's going to take us at least a few weeks of working on this to set up the best practices, to start setting up a test suite, to set up continuous integration so that we've got the build happening and then being deployed out to a server automatically. And there are other cases where the client comes out and says, well, I need something that is more or less complex, and we've said no, we're not going to do it. And we're a consultancy that does pretty well with business coming in, and so luckily we can afford to do that. But I'm sure that you've been in situations too where you've had a code base dumped on you and you've said, I have no idea how quickly I can start developing on this, right? If ever. And so we had a lot of projects in Ruby where we would just tell the client, no, we can't really give you any kind of prediction on this. We probably have to rewrite it. That would be actually quicker than going in and hacking on this code base. Because we just don't have any confidence that we can deliver features in a timely manner. So this project was very interesting because it was actually coming from a team of electrical and mechanical engineers who didn't have a ton of experience in software. And they were really smart guys. They had taught themselves Haskell. But the code base didn't have any tests. It didn't have continuous integration set up. And so I was a little bit skeptical at first. But it turns out that our developers were able to pick up working on this project and be productive the first week. Which is something that I never would have anticipated in Ruby. They were able to look at the application. They learned about the domain from the types that were defined. And they tried breaking stuff and seeing what would compile. It's kind of a brute force approach, but I really think that this is the kind of project that didn't adhere to all the best practices. That if we had received in Ruby, we might have been like, well, we don't really want to take this one on right now. Good luck with it. So Haskell really had a very tangible effect on this project. This was done half by a developer in New York who had a lot of experience with Haskell, and also partially with developers in Ecuador. We have a couple of developers in Ecuador now who came from Java backgrounds, fresh out of the university. And within a few months, they were very productive in Haskell, including on applications like this one. We recently started as well on an internal product, and this is to gain some more experience in Haskell, to keep trying new techniques, maybe play around with some front-end components. And we're using, on our main Stack Builders website, we're using Hackage, which is a web programming framework. And on most new projects, we're using Snap. And in some of the internal projects, we're also thinking of experimenting with Elm. But I'll mention that in a moment. The other web framework that I should have mentioned a moment ago is Yesod. And Yesod tries to be more like Rails, that has like all the batteries included. And the one external client project that I mentioned is using Yesod. And that's been working really well too. The author is really prolific in the Haskell community, Michael Snowman. And he's really produced a lot of great libraries. So what are some of the good parts about Haskell? It's really stable. It's been around for 25 years. It's an older language in that sense. It's got a pretty active community. Haskell started early on with a large community it started out with Cabal relatively early. So from what I've heard, I think that OCaml took longer to formulate a common pattern for contributing libraries, and the fact that Haskell did that early really helped out. And so now we've got about almost 1,000 packages, I think, or something like that on Hackage when I was looking. and they're rapidly increasing. Cabal and Hackage work pretty well for package management. Now, this is still quite a bit less than something like Node. I looked in Node this morning, and there were, I think, 128,000 packages. So, you've got these communities with all this stuff and all of these batteries included in frameworks. And Haskell isn't quite there yet. And I think that's something that'll continue to improve, but at the moment it's not, it hasn't been a huge barrier to have a lack of libraries. Haskell is really getting better too. So there are things like Cabal, and the previous speaker was mentioning how Cabal in Haskell was perhaps more developed than things in the OCaml community. I think that's true, but it also has its pain points. A lot of people, when they talk about the difficult parts of Haskell, do talk about the tooling and how you try to install dependencies and all of a sudden it's saying max back jumps reached or something like that, and it couldn't work out the dependencies internally. That stuff has really improved a lot even over the last year or so. Cabal added the notion of sandboxes, where you can basically install the dependencies per project, and that's been a huge help. As with any other one of these communities, it's open source. So if you don't like it, you can jump in there and start fixing it yourself. And this is actually something that I did with Cabal recently. I looked at the issue tracker for Cabal, and it had almost 700 open issues. And so there's obviously no deficit of places to start working. And I just went from the back all the way back to 2008 or so, and started picking off some of these issues. And many of them weren't even related to Cabal. It was related to Hackage or some other project, and just nobody had bothered to clean them up. So I started doing that. And then shortly after, the really cool thing is that other people in the Cabal and Haskell community started doing the same thing. Other people started picking up old tickets and cleaning it up. So you've really got a great community of people involved in Haskell and committed to making it better. And I think that's really a lot to be said about Haskell, because in the end, this is a quote from my friend Michael Bernstein. He said, "I wish we could all acknowledge that Haskell is kind of a boring language," and so this is boring in the good sense. Michael likes Haskell, and I think that in many ways we want a language that's boring, a language that's stable, a language where we can go in and usually things just work, and that's really the case with things like Cabal. With the language itself, and we just haven't had a whole lot of surprises, which is fantastic. We've been very productive in it. So let's go on to selling Haskell. And these are my two kids down in Ecuador. They have a festival that's called Carnaval, like they have in Brazil, and it's basically a bunch of kids like spraying each other with this silly string, this foam kind of stuff. And so we haven't had all successes in selling Haskell. We've approached some clients, and they basically just said no. So there was one large client that we had, and we had a part of the system that was pretty easily able to be decoupled, and we said, hey, we'd like to use Haskell for this. And we actually wrote a prototype on our own time in a couple of days. Turned out to be like 100 times faster, something than the Ruby version. It was clearer to read, kind of the stuff that we expected. Worked out great. Went back to them, and they said, look, we've got 500 C# and Java programmers, and nobody knows Haskell. And so no. And this wasn't totally unexpected. It was pretty disappointing, but this is something that we do all face in trying to push our favorite languages forward. What do we do to get around this? We tried a bunch of different approaches. We said a bunch of things, and I'll kind of share some of the selling points that we used. But at the end, it wasn't effective, and they're not going to go with it. It turns out not only do they have .NET and Java programmers, but nobody's even doing F#. So we didn't even have that going for us. So we just got permission denied, and tried using the sudo use Haskell approach, which in this case meant going back to our own internal projects with some of the Haskell developers. And giving up on that front and planning on trying again later. So how do we sell Haskell? And I think this is this can be applied to other languages too. Whether you're trying to sell Erlang, trying to sell languages like OCaml. There are a few things that I've tried to pick up here, and one of those is that I think that a lot of people come out and they say, well, Haskell is just safer. I don't know if that's necessarily the right selling point in a lot of cases, because people think of safety and they say, oh, that means you're going to be really slow, right? And that's not the message that we want to convey. It is safer in many ways, but really the reason we use it is that it's more productive, right? We get immediate feedback from the types. We figure out exactly where something is calling something with the wrong arguments or the wrong type. So that's why it's great. Safety is cool too, but that's not the only thing. And it's not just for geniuses. Some people say that Haskell is really hard to learn. Actually, I think it's for programmers like me, programmers who make mistakes, right? If you've ever made a bug, caused some kind of a bug in a program, Haskell really excels. It doesn't just excel for the geniuses and the people who can teach themselves 10 languages in a week. It excels for everybody else who makes mistakes like a normal human. What about maintenance issues? This is something else that a lot of people will mention. And I think that in Haskell, they might say, well, who's going to take care of this application after you leave? And I think there are a lot of strong points that can be made that Haskell is perhaps actually easier to hire for than Ruby. At least in communities like New York City, a lot of the best developers have left communities like the Ruby community. And recently, we haven't had a lot of luck hiring for Ruby programmers. In contrast, I think there are lots of people who are really passionate and enthusiastic about learning things like Haskell. And as I've said too, it's not even that hard to pick up to begin to be productive. So I think that sales is part of all of our jobs in software. You might not like this, and perhaps you even went to the university in engineering to avoid doing sales. That might have been one of the reasons that I did it initially as well. But in the projects that I've been on in the course of my career, what happens? You get onto a new project with a client, they give you the 200-page specifications, expect you to go off and build it, so you have to convince them to use Agile, convince them to use a reasonable process. They want to use COBOL, or they want to keep maintaining this legacy system in Ruby that doesn't have any tests, and you have to convince them to build it a different way. So I think that we can all become better at doing this, and we can create more effective systems if we get better at some of these skills. So there's a book by Robert Cialdini, and I think that it's actually a pretty good sales book if you're interested in getting better at this, because, like I said, this is about software too. And he states a bunch of principles that I won't go into in detail due to lack of time, but things like reciprocity. Tell the client, hey, maybe we don't want to go in this direction, but let me try doing some Haskell development for a couple of days on my own time. If you give somebody something, there's a very good chance that they're going to reciprocate and do a favor for you. So maybe you'll just get Haskell or OCaml or Erlang in the door that way. Committing to Haskell and saying you're going to go through with it or anything else is really useful. Social proof, so saying, hey, there actually is a community of people doing Haskell. It's actually big in New York and a lot of financial institutions. Being likable and presenting yourself well. Coming from authority. This actually isn't a problem for Haskell, so I don't know if I would recommend using this. I mean, there are already tons of academics who talk about it all the time, which is good, but I don't know if we need more authority in a lot of cases. Or scarcity. This is my personal favorite. With languages like C#, Java, adding lambdas. Say, look, we're almost out of lambdas. We gotta use Haskell all the top. Right? So. Let's go on to the future, and then I'd like to open this up for a discussion too. There's lots of cool stuff going on in Haskell and pure, strongly typed functional languages for the front end too. And even though we've been using things like Ember, there are really cool frameworks like Elm, which is a functional reactive programming framework for the front end, and PureScript, and also GHC.js. So this is an example of Elm. And if you haven't played with it, you really should go out and give it a try. You can type right into the browser. You get immediate feedback. So this is a Mario game that simulates gravity and all that kind of stuff. And it's functional reactive programming. So it's actually pretty, it's declarative. You basically put all these events, input events, through a fold and go over and modify those. So this is a game that my kids like playing. And when they get a little bit older, I'd like to teach them how to do some programming in it as well. There are things like PureScript as well, which I haven't used, but that seems promising too, in the same kind of vein. And finally, you can just use Haskell. And this is a newer project called GHC.js, but basically it's a fork of Cabal right now that'll probably be integrated into the main Cabal repo soon. And basically all of Prelude compiles. Most Haskell programmers just compile, unless you're using something like native extensions. And you can start using it and load up your program. So there are certainly some limitations, but it's a very promising direction. So finally, since we had I added this slide while I was listening to the previous talk, and not to refute that, I think that OCaml and Haskell are both great languages, and I would probably use OCaml if we didn't have Haskell. But there's, I think that some people will mention things like syntax extensions in Haskell. And how things change based on which ones you're bringing in. I don't think those are necessary to be productive, and I still don't know all of them. So I don't think that's something that you should be scared about. I think that it's got great support for concurrency in control.concurrent. I was able to be productive in writing simple concurrent programs in Haskell in a couple of hours after I already had experience with the language, and that just seemed really elegant and simple to me. They've got things like Hugel and Hayu, where, unlike the scenario where you go into the closure IRC room and say, hey, what function does this? You just type in the signature that you want into one of these tools, and it tells you what functions line up with it. It's got Cabal, which is pretty good package management. Even though it has some rough edges, it's already there, and it works in a lot of cases. Things like Quick Check, and one of my personal favorites is HSpec. So this is kind of like Ruby's RSpec and similar syntaxes in other languages. Really elegant. You kind of just make a describe block, an if block, and then you've got essentially what are unit tests with just a little bit more syntactic and concise syntax. And so HSpec is really nice. It also does auto discovery of specs, which is useful. Finally, it's supported in Travis. Maybe this is one thing that it's got up on OCaml, at least for the moment. You can just type in the language GHC, and then it works for a few different GHC versions, like 7.4, 7.6, and 7.8, and pretty soon 7.10, which is coming out. I think that it actually seems like OPAM and OCaml is catching up really quickly to Haskell. So I don't know how much of a difference this is anymore, but Cabal has been around for a while, and there are lots and lots of packages. So I think that in the end, the future is really bright. There's a lot of stuff that we can do with Haskell. We can be productive today. But I think that this isn't all just about teaching people Haskell and using Haskell. I think that the important thing is that we continue to experiment. As software developers, we have a responsibility not just to write systems for our clients reliably and in a way that we deliver them and they'll work, but also to push the industry forward. So even if you're using something that isn't the most popular, if you feel like it's going to help make better software, then let's push it out there. And Haskell is ready to use today. So that's all that I have. I don't know if we have a minute for a question.
Sure, thank you. That's nice stuff. Now we have some time for questions.
Have you ever tried ClojureScript for frontend instead of GHC.js? I mostly do JavaScript work, so
Yeah.
GHC.js has a rough edges, a lot of them.
Yeah. It does. I wouldn't. We haven't done ClojureScript. We've done some Clojure backend. I really like the statically typed direction since I think they have a lot of benefits, but I would agree that GHC.js is not there yet. If you really want to do something like that in the front end, you're probably better off with something like Elm.
Hi, sorry. So what is your deployment story?
Uh-huh.
And also, how do you provision different developers' machines so they match those dependency hell?
Yeah. Well, to tell you the truth, I think that Cabal Hell has gotten quite a bit cooler. It's not quite as bad anymore with things like Cabal sandboxes. You have to start by using a Cabal sandbox, which is an isolated set of dependencies for every project. And once you do that, I don't think it's so bad. Deployment, we have a couple of different approaches that we use. There's a really hacky Cabal program, or a really hacky Haskell program that I wrote called Papistrano, which is based on, it's pretty bad code. If anybody else wants to take it and fix it up, let me know. But it's out there on Hackage, and basically it does the same thing as Capistrano, sends the code out there, it does the dependency install. Since installation can take quite a while, it just does a symlink at the end and points to the new app. So, pretty simple. You can also do the same in a 10-line bash script, which we do on some projects too.
Do you just use Max, or do you use Linux as well? Because maybe you have that nice experience because you're a Mac.
We have Macs and Linux, a mix in the environment. There's one more thing there. There's also a package that's supposed to be really cool by this guy named Metek, named Halcyon, and I haven't tried it yet, but it's supposed to be really sophisticated and cool. So just a shout out to his package that I would suggest people try.
Question here.
It seems like you worked with Ruby for 6 to 7 years, and now you chose Haskell, but I think the problem was you were not using type language. So if I go with Scala instead of Haskell, will it be the same case like Haskell, or do you think Haskell is the only solution to achieve this?
No, I think that's a good question. I mean, I don't want to start a religious war. I think that we can get better. We can do a lot better than Ruby, and I think that even Ruby can do better than Ruby. Because Ruby is doing things like adding gradual typing, perhaps, or at least the author is talking about that. I think that Scala is probably more maintainable in some ways, and it's got its own complexities too. I think the Haskell is pretty elegant, pretty simple. As far as I know, they never added an object-oriented system that's stuck on top of it. So you've kind of got like one paradigm there that works, and it seems to work pretty well. But I think Scala is good too, but I'd encourage you to take a look at Haskell and tell me what you think.
Okay, one question from here, and
sure.
Maybe
what materials do you use for training new developers to become proficient in Haskell?
We've got this big thing in the office called the fireplace. We just toss people into it. No, there are some books that I think a lot of people use. There's Learn You a Haskell for Great Good, Real World Haskell, which is a little bit dated. Some people who are really into Haskell learning, like on the Haskell Beginners IRC channel, recommend a different set of resources. But there's lots of good stuff online that also brings you into kind of the meat of the language pretty quickly. But I think just a real-world experience, like I said, most people are productive in a few months coming from Java, and they get that way not just by reading, but by being tossed into the fire.
11 million developers today. Well, if clients use Haskell, what these developers should do then? Because now they're mostly fixing bugs, right?
I'm sorry. Can you say?
Yeah. Currently, we have 11 million developers. Mostly they are fixing bugs, right?
Yeah.
So if clients says to Haskell, then what? Because
what are we going to do? I mean, I think we're going to have an unemployment crisis.
no bugs, no helps. Okay, the final question.
How big infrastructure do you have on your projects? How well does Haskell Project scale? And how it communicates with other projects?
Sure. So at this point, the largest applications we have in production are Ruby ones, where we've got clusters of 10 or 20 servers doing different things. The Haskell applications that we have are more monolithic, kind of just standalone web apps using Yesod or using Snap. But honestly, we're Ruby programmers, so if we're going to Haskell, it's already 100 times faster. So usually we don't have that many problems, with things like scale. So we haven't had a lot of scaling Haskell problems. We've been really happy with the efficiency as an immediate and pretty much free speed up to runtime.
Okay, thank you for this presentation again. Thank you for nice questions.